Hello everyone and welcome to the Top New Radio. So today we are going to discuss about 5G NR, that is 5G new radio. So let's discuss about the 3GPP standards and the new radio timeline. So there is a NR technology which is new radio technology. So NR is basically a new radio access technology, and this technology is developed by 3GPP for the 5G mobile network. This technology was designed to be the global standard for the 5G air interface. So 5G new radio will utilizes the modulation, waveforms, the different access technologies, and this will enable the system so that it can meet all the need of high data rate services, low latency, etc. So this is built on our established technologies to ensure the backward as well as the forward compatibility. Now, with all the new levels of latency, reliability, security, the 5G new radio will scale to efficiently. It can connect the massive Internet of Things, and this will offer the new types of the mission critical services. So we have a different standards that are known as the 5G new radio standards. 5G new radio standards are published in the release 15 specifications, and these are further developed so that it can include all the new features, functions, and the different services. So new radio will define the air interface that will support the next generation communication connectivity also. So 5G new radio standards, this will consider like we have different standards for standalone and non-standalone operation of the new radio cells. So in the non-standalone operation, this new radio cell will uses the LT cell as a control plane anchor. So in new radio operation, that means in non-standalone mode, the new radio cell will use the LT cell. The mode is a non-standalone and the deployment is non-standalone deployment. Because in a non-standalone deployment, there is a dependency on the 4G network also. So we have to switch back to the LT cell. So the new radio cell will switch back to the LT cell as a control plane. So LT cell will act as a control plane anchor. Whereas in standalone operation, that means that is completely 5G network. So in standalone operation, the new radio cell has a full control plane functionality. In non-standalone mode, there is a dependency, but in standalone, there is fully control plane functionality is there in the new radio cell. So it has a different use cases like we have enhanced mobile broadband. There is a mission critical control services or mission critical services. There are massive connected devices which have ultra reliability, low latency communications, and all of these in frequencies above and below the 6 gigahertz. So these are the different new radio applications. Now, if we can see that all the applications of 5G new radio, these are categorized into three parts. We have massive Internet of Things, we have mission critical control services, and we have enhanced mobile broadband services. So 5G new radio has three different services: massive IoT, massive critical control, and enhanced mobile broadband. So under the enhanced mobile band, we have extreme capacity, and this extreme capacity is around 10 terabits per second per kilometer square. Sorry. Then we have ultra low complexity, and we have deep awareness. All of these under the enhanced mobile broadband. Moving to the next, which is mission critical control services. There we have a strong security. We have ultra high reliability, extreme user mobility, and all of these under the mission critical control services. Moving to the next, we have the different category, that is massive internet of things. Under this we have deep coverage. In the deep coverage, it can reach almost all the challenging locations. Then ultra low latency or energy. Then we have low complexity and high density, and high density is about 1 million nodes per kilometer square. Under the ultra low complexity, we have 10 second of bits per second. And ultra low energy, that we can guarantee 10 plus years of the battery life. The next we have the timeline. Under the timeline, we have the different years and the different releases. Why we have release 15, release 16. So we have 5G new radio release 15 non-standalone, then we have standalone, and different evolution studies towards the different releases. Next, let's talk about the 5G technology enablers. So all the technology enablers, we have optimized OFDM waveforms and multiple access. Optimized OFDM based waveforms and multiple access, like we have orthogonal frequency division multiple access based waveforms and the multiple access techniques. We have scalable OFDM numerology, and it has a scaling of the different subcarriers. See, in OFDM we have number of subcarriers. So under that we have a scalable numerology of the different subcarriers. We have a concept of 3D beam forming in this. Then new radio architecture, the massive MIMO concept is there used in the new radio. We have advanced spectrum sharing techniques. There is a concept of wave radios, network slicing, denser radio deployment also. Moving to the next, we have all the benefits of this 5G new radio. Now let's talk about what are the different benefits of 5G new radio. We have a larger wireless area capacity with this. We have an increased energy savings with the new radio. Then there is a lower period of time, like between the updates, we have a lower period of times, and average service creation time cycle is also very less in this. So improved links, there is a improvement of the different number of links that connects the larger number of the users together in a one unit. We have improved technology for maintaining the quality of a connection over a greater or a broader geographical area. So there is an improved technology that can maintain the quality of connection. Then there is an enhanced speed and data rates. Then improved efficiency is also there in the data sharing. So this will be able to deliver a huge number of the services that will be varied across the diverse set of devices. It has a different performance and latency requirement also. This can support a wider range of deployment models, like we have a traditional macro deployment of the cells. Now we are into the new or latest hotspot deployment. So all of these will be provided by the 5G new radio. That is the benefit of the 5G new radio technology. Moving to the next benefits, like it allows a new ways of devices to connect, that how the number of devices can connect. Like we have connection of device to device connectivity and device to and multi-hop or multi-hop mesh network creativity. All of these are supported by the 5G new radio. New radio is a part of a wider flexible network architecture also. This is being designed to improve the performance, we can improve the scalability, flexibility, and efficiency of the mobile networks also. Now, 5G new radio is able to use most of the spectrum. It can use the licensed, it can use the shared and unlicensed across a wide variety of the spectrum bands. So these are the number of the benefits of the 5G new radio technology. So next benefits include the spectrum. So let's talk about the 5G new radio spectrum. To deliver the highly reliable, ultra low latency, multi-gigabit connectivity, the 5G technology promises spectrum for the different services like low, mid, and high band spectrum. The 5G technology make use of licensed, it may use the unlicensed and the shared spectrum also. Now we talk about there is a low band, mid band and high band spectrum. The low band will offer the wider coverage and deep signal penetration. So if you have a requirement of 5G technology, that means you have to plan the spectrum accordingly and you have to plan spectrum in such area where you require the wider coverage area and deeper signal penetration. There must be use of the low band spectrum. Then wave bands, they are very critical so that they can provide a multi-gigabit connectivity, and you can use the extremely wider bandwidth capacity. So for the multi-gigabit connectivity and wider bandwidth capacity, there is you can use the wave bands. So all of the wave bands, they consist of the much larger amount of spectrum than those are available in the lower bands. Now, by using these wider bandwidth and 5G advanced antenna technology, the wave bands will use EMBB, that means enhanced mobile broadband, ultra reliable low latency communication, and massive IoT for a wide variety of services and devices. There is a concept of the dynamic spectrum sharing. Now, what is this concept of DSS, which is known as dynamic spectrum sharing? This enables an operator, basically you can use an operator and it can run the 5G in spectrum which is already in use in 4G. So you have a 4G spectrum, now you have to use that for the new technology. So that means the 5G technology, you can use the concept of the DSS. Now, the amount of the spectrum that you are using for the 4G and 5G in a cell changes dynamically every time. And this totally depends upon the requirement from users at any time. 5G technology and the 5G spectrum allocation is very important for the industrial IoT development and its use cases. Now, if you want to bring the 5G to all the places that can drive gains, you can have a gain in productivity, you can have a gain in economic growth, and also there are the multiple other benefits that you can have with the 5G technology. Now all the private networks, now there is an era that you are creating your own private networks in your community or area. So you can use there in private networks, there is a use of licensed bands, unlicensed band, dedicated bands, and shared spectrum also. Now like we have a sub 6 gigahertz. Sub 6 gigahertz is a spectrum or a range of frequencies that is a very good mixture of coverage and capacity. That means this band can give you a very good coverage, they can give you a very good capacity, while wave spectrum can give you ultra high throughput and low latency requirements. So as per your requirement, we can choose the spectrum. In a 5G deployment, we already have seen there are multiple deployment options. Like we have standalone option 1, 2, 3, 7, 5. So standalone option 2 can be required for the mmWave private network deployments where verticals need a fully isolated network. So if you require a completely or fully isolated network, we can use this type of spectrum. 5G new radio standard supports low, mid, and high frequency bands. It is divided into, like the bands are divided into FR range, frequency range 1, and frequency range 2. So frequency range 1 frequency bands are less than 6 gigahertz, and frequency range 2 includes bands with a lower range that is combined with the higher range and mmWave. So frequency range 1 has 410 megahertz to 7125 megahertz of the range. Frequency range 2 has 24.25 gigahertz to 52.6 gigahertz of the range. So we have extend 5G with unlicensed spectrum, like we have licensed spectrum that is exclusively used over 40 bands globally for LTE. So this is industry top priority. Next is the shared spectrum. We have 3.5 gigahertz USA and 3.7 gigahertz Germany. Unlicensed 5 gigahertz, 6 gigahertz, 60 gigahertz, which are globally used. We can unlock the more spectrum. We have new markets and verticals and new deployment option. So this is 5G radio spectrum. Mid band is 1 gigahertz to 7 gigahertz. This can give you a mixture of coverage and throughput. Low band is frequency range 1, 450 megahertz to 1 gigahertz, which can give you good coverage and throughput is less. And high band FR range 2, coverage may be low, but throughput is very good. So this is how the bands are divided accordingly. So thank you so much for attending today's live session.